So we're going to make a few comments about single pole op amps. And examples of single pole op amps would be our single stage op amps, for instance. And we note that even a single stage op amp likely has more than one pole, but one of those poles is probably so much larger than the other pole that it doesn't cause any issues. But the comment we'll make about a single pole op amp is, first, the feedback can never reach minus 180 degrees. In other words, what we're saying is the angle of our loop gain function, T of j omega, can never be equal to minus 180 degrees. And what this means is that our system is always stable. We don't ever have to worry about positive feedback in this system. Now, we've made this point, but this is not true if beta has frequency dependence. In other words, if we had a beta that has a frequency dependence, beta can contribute a pole to the system. And if it contributes a pole, then we have potential for instability. Now, our second thing is an op amp circuit with a single pole op amp and constant non-frequency dependent feedback is always stable. So we don't have to worry about ringing or oscillation. Now, examples of single pole op amps. And our first example would be to use a fully differential op amp. So instead of using a current mirror load, we just use a fully differential stage, and then we have one pole at each of the outputs that's exactly equal in frequency, so we don't worry about stability. Now, the other thing that we can do is use some kind of single stage op amp like a cascode. You can use a telescopic cascode or a folded cascode. Or we can just use our single stage source coupled pair with a current mirror load, and we have a pole due to the current mirror, but that pole is likely at a very high frequency, so it probably doesn't impact the stability. So this is just like any other analog design trade-off. If we have an issue where stability is going to be quite a concern, or we have to operate our amplifier up to very high frequencies, we might have to suffer a trade-off between gain and stability. And so we might have to choose one of these topologies in order to make that happen. Now, in the next lectures, we'll start looking at stability of multi-pole systems, and of course we'll start examining exactly what happens with the two-stage amplifier that we looked at briefly in this lecture. We'll do more critical analysis to figure out stability considerations, what's the total gain of the circuit, and what are the other operating conditions of the circuit.